talked about the role of evidence yesterday, but we need to refresh that. The idea of the evidence is this last bullet point here. Remember, it's to convict somebody, okay? But how do we convict one? Well, we make it so compelling, so overwhelming, that there's no way they can get out of it. You ever heard the term, don't bring a battleship, don't sink a canoe with a battleship? Have you ever heard that? Well, we always want to sink the canoe with a battleship and a carrier and a flyby by the jets to go ahead and drop a couple of bombs on them. We want to make it so compelling that the court goes, listen, dude, I don't care what you say. Everybody knows you're guilty on this. And are you sure you want to plead innocent at this point? So that's what we're trying to do. And that's really what the evidence is going to do. Now, you do it in a disconnected manner as a scientist to say, this is the progression here, and here's where this sits. Because remember, the opposing counsel is going to take the exact same evidence, and they're going to try and figure out ways where, hey, that was really your roommate that installed that program. That was really somebody else that did that. And they're going to chip away. You're going to create your mountain, and they're going to chip away at your mountain. So just like the scales of justice, it's going to balance out, and hopefully it's in your favor. And that's what you're shooting for. Okay, so what would make the court accept your evidence? What characteristics, high-level characteristics, make your evidence compelling? Well, it has to be believable. It has to be reliable, complete, authentic, and admissible. Those are your 5 goals of evidence. Believable, okay, you know that. This isn't some fanciful thing where he had to go through all these steps to get this done. It was very simple. He opened up the website, he clicked download, and the information was there, and he's got CP on his machine. That's believable. But if he had to go through 80 steps to get there, and it took a long time, remember you reproduced it in the lab? If it took you 60 or 70 steps to achieve this same result, that's really not believable. But if you just click the button and boom, this was done, very believable, very reasonable at that point. And it also fits in with all the other evidence that's there. Reliable. That this is a standard way that things are done, everybody agrees to it. Complete. It's whole. We can't have half of a data file or half of a registry setting. It's got to be all there. And it's also a complete picture. So it's the whole thing. And also there aren't big chunks missing from the evidence itself, because that could be the piece of evidence or the part of the system that disproves all of your theories. If this piece were there, then none of this stuff would actually happen or be realistic. But that piece isn't there. Where's that piece? That's, again, when we go to the crime scene and we collect up all the evidence, we sketch it and we take lots of pictures of it. Authentic. When we talk authentic for us in a court of law, we're really talking about MD5 hashing, which we'll talk a lot about later on. Admissible. Was it obtained properly? Or did you just run down the street and see somebody with their phone and grab their phone out of their hand? It doesn't work like that, right? Okay, the types of digital evidence, there's 2 main types, but then what we're going to see is there's a couple of other ways that we can talk about the evidence. Our first is volatile and non-volatile. Volatile is it can be modified. The 2 classic places that we discuss volatility is in a cell phone, because there's lots and lots of signals going in and out of it. That's a very volatile thing, so we protect that. We'll talk about how in a bit. And then on a computer, we're also talking about within that smartphone or that device or computer. Now we're also talking about RAM, swap files, those places. Non-volatile is really what we want. Because when we go in, we're not interacting with the operating system anymore. What we've done is we've pulled a copy of all the operating system files and actually all of the physicalness of the machine. And we're now examining that copy of it, not as it's running, but as a static file. So that's really what we want to do. So, okay, so where is that? That's on hard drives, removable devices, thumb drives, memory cards, printers, and sometimes in the slack space. Printers is one that's a little odd. You'd say, well, it just puts ink on a page and spits it out. More sophisticated printers these days actually have hard drives and storage in them where you can actually reprint your last print job as a convenience thing. So maybe the paper popped out the wrong way. Well, let's go back and reprint that print job. Everybody wants to grab the computer. It could be as simple as reprint the last fax, reprint the last job, and going to the printer and doing it. And there pops out all the evidence. You could also organize data, digital data, by talking about the concept of transientness, shares, network connections. So when this machine is on, started, booted, and we've logged in with this profile, we're connected to our Dropbox, we're connected to our Pogo plug. How do we get there? Well, we've got to go over an IP network. Well, how do we do that? Well, we got to get assigned an IP address. If we get assigned an IP address every single day, there's probably a device, maybe a router, or some tool that's actually got BootP or DHCP inside of it that's handing that address off and then allowing us to route through to get out to the internet. When you connect up to Dropbox every day, you're going to leave an artifact there. Go back to Locard's principle. What's going to be there in these transient pieces of data? Fragile. All data is fragile. All digital data is fragile, so we just have to realize that we have to keep that uppermost in our mind. This stuff could break. There's an excellent online video about somebody running a hard drive without a cover on it. And they actually ran it and they got it installed. They got the operating system installed on an uncovered drive. And it ran pretty well with a few errors here and there. And then they decided to see how far they could push it. And they dropped water on it. And it actually spun and it worked. But then when they poured water in it, it was pretty much over with. So they show you how not fragile, how sustainable these drives are in a lot of cases. But as soon as you start mixing electricity with water, bad things happen. They call it letting the smoke out. Metadata. That's another type of data that we're interested in. Not the actual Excel file, but the number of times this Excel file was saved, the number of revisions on it, the last date that it was saved. If you go into any file that's on a Windows machine, you right-click and you choose Properties, you'll see the external metadata. When you actually open that, let's say you go to that Excel file and you open up Excel and you say, show me the file properties, another set of metadata inside of it is actually revealed to you that can tell you a lot about this particular document. Finally, residual data. What's left over when we do things like delete or update or change the system in any way, shape, or form? Is there something left over that we can kind of scrape up the pieces of and will get us where we're going? Now, that residual data could be metadata. That residual data could be true data. It could be shared information. A classic example of residual transient information is your, in Windows machines, the remembered wireless access points, that list of all the places that you've been with that particular device. Remember, the computers know that they've seen this network before in a lot of cases, so they'll keep that in a registry file. What we want for evidence is the best evidence rule. That's what we're shooting for. You and I, as forensics investigators, we don't get that. What we want is, I saw him kill her. Boom. That's direct. We don't have that. Okay, so what we say is, okay, what's possible in our world? Well, since it's usually a computer or device, that computer or device records a lot of data over a long period of time. Also, maybe the people that you're paying will actually record that data over a long period of time. Classic example of this is your cellular bill telling about every single phone call that you've made. That stuff is hearsay. We have a hearsay exception, and we can move on from there. The exception is that this is a regular course of business in this computing process. This works more in a corporate setting than it does in an individual setting. It's not totally lost in an individual setting, but it works better corporate-wise. Okay, now let's go back to some considerations for collecting evidence. This causes us some problems we need to deal with, and we've seen it before. Don't run any programs on the compromised system. You go, but Dean, We want to capture the RAM and we have to run, well, then you're going to have to record that change. Don't run programs that modify the metadata of files and directories. This happens a lot more on phones where things get stomped on. This happens a lot more in insertion devices, like if you insert a USB drive into a machine, it will actually change it. So be prepared to record that and say, we don't want to do this, but when we do this, record everything. Write the results of the investigation to a remote location. Okay, so figure out when you're dealing with this remote location how it's going to work with you. Calculate the hash values at that on that particular data, and that tells us that it has not been changed. That's the first thing that we do, is we run that MD5 hash against that evidence to protect it. Here's what's really nice about the hardware disk writers at this point. A lot of the more robust devices, you take the original evidence, you plug it into the, it's a big box really, usually they're Pelican cases. You plug the original drive in and you plug in 2 reference drives into it. As it copies the data from the original drive to the 2 reference drives, at that time it also calculates the MD5 hash physically. And so that's a really elegant way to do it. Look for those tools. So we're going to talk a little bit about handling evidence, but here's the rule. The rules change all the time. Here's the general rules, and we'll do our best to kind of stick to those rules, keep those uppermost. If the computer is turned off, don't turn it on, because we just want the hard drive out of it, and there's no data residual at that point. If you're on an incident responder team, a first responders team, try to let the forensic specialist handle it. Look for the senior investigator to actually drive this. If the computer is powered on, collect up as much information as you possibly can. If it's a remote computer that is plugged in and running at that point, figure out what the power needs are for that particular device. Supply those power needs before you disconnect the computer so you can carry it while it's running with a UPS. Whatever condition the evidence is in, take lots and lots of pictures, document that, photograph that, draw that. You want as many photographs as you can possibly get. Some people would say, hey, why don't we just do video of this? In a lot of cases, what happens is video evidence collects more than you actually want from the crime scene. And so you just focus in on the elements that you're supposed to portray. Document the connection of the external components, how they're plugged in, where they're plugged in. Any kind of pre-existing damage that's on them that could be used against you as to say, well, this was corrupt and it wouldn't work. You need to take pictures of that as fast as you possibly can. When we talk about evidence and the processing of evidence, one of the masters out there is Casey. And let me say this. You buy Casey's, if you can't afford his 3rd edition that's out, I'm sure that you can purchase a 2nd edition for $4 or $5 at this point. Buy his book, read his book. It's kind of the Bible for starting off with investigations. And he came up with this process according to him, and he calls it the stair-stepping analysis. And he goes through each one of these steps here. First 4 steps. Create an investigative methodology that works for you, but also, here's his. Accusation or incident alert. Know that it's occurred. Assessment of worth. Is it valuable for us to go after this? We do a risk assessment there to see whether it works. Incident crime scene protocols. Well, what are you following at that location? And especially if it's law enforcement, they'll give you very clear direction on what you should be doing.